Hello and welcome to the last section of Unit 8. Alright, so this one is probably going to be kind of confusing, especially because these words are so similar. So we're going to be talking about rational and irrational numbers. So a rational number is a number that we've dealt with most of our lives in math. Rational number is any whole number or any number that you can put as a fraction. So if there's ever a number you can write as a fraction, any whole number you can write as a fraction, then it is a rational number. So all these are examples of rational numbers right here. And then these are all rational numbers. Irrational numbers are any number that cannot be written as a fraction. So it will be a decimal that goes on forever, but has no pattern at all. So what we're going to be looking for most of the time for irrational numbers is something inside of a radical sign. So notice up here, just because it's inside of a radical doesn't mean it's not rational, because if we have a square root of 4, that is equal to a whole number. But anytime we have a radical sign that is not equal to a whole number, it's irrational. So this is one number, because if I added 5 plus the square root of 3, that would just be one number. But it's also irrational because part of that number is inside of the square root. A square root of 3 does not equal a whole number. If I multiply square root of 3 times square root of 16, that does not equal a whole number. So those are irrational. Pi is also an irrational number. So in the first example, we got to simplify these and then write if it is irrational or rational. So 5 radical 7 minus 8 radical 7. So the root 7s are like terms. So that means I'm just combining these two like terms. So 5 minus 8 is negative 3 root 7. So this is my answer. Now there is a square root of 7. Square root of 7 does not equal a whole number, so that means our answer is irrational. Irrational. So next number, I got 3 plus 4 root 19, and then plus 5 plus 2 root 19. So since there's a plus here, I'm basically adding all these numbers. So 3, I'm going to put the two whole numbers first. So 3 plus 5. Plus 4 root 19, plus 2 root 19. So all I did, since all of these are plus signs, I just reordered it to put the whole numbers together and the radical signs together. So 3 plus 5 is 8, 4 root 19 plus 2 root 19. So again, the 2 root 19s make these like terms, so I'm just combining these two like terms. This one has 4 root 19s. And I add 2 more root 19s together, so now we have 6 root 19s. So this is my answer. So again, part of our answer has a radical 19, which does not equal a whole number, so again, it's going to be irrational. So the next one, we are subtracting these two things. So if I distribute that negative sign, 4 plus 4 root 3 minus 2 minus 3 root 3. So combine like terms. 4 minus 2 is 2. 4 root 3 minus 3 root 3. So I had 4 root 3s. I took 3 of them away. That means I have 1 root 3 left, or just root 3. So this would be our answer. We have a radical sign. In our answer, it does not equal a whole number, so again, it's irrational. Next one. So I'm going to distribute that negative sign. So negative 7 plus 5 root 7 minus 3 minus 2 root 7. So combine like terms. The whole numbers are negative 7 minus 3, so that's a negative 10. 5 root 7s is what we started with, then we took away 2 of them. So we'll have 3 left. This is our answer. we have a square root or a radical sign in our answer that does not equal a whole number, so again, it's irrational. So moving on, so this one, I like to since we're multiplying, I like to reorder it. So 5 times 2 times radical 7 times radical 7. 5 times 2 is 10. Another way to write root 7 times root 7 is the square root of 7 times 7. We got a pair of 7s, one goes away, the other one comes out. So that equals 7. So anytime you have a square root of a number times itself, it's always going to equal that number inside there. So square root of 7 times square root of 7 is going to equal 7. So 10 times 7 is 70. So since we get a whole number for our answer, it is rational. So on the next one, I'm going to multiply the two whole numbers together first. So negative 3 times 4, and then I'll have square root of 3 times square root of 7. Negative 3 times 4 is negative 12. Square root of 3 times square root of 7 is square root of 21. And that would be our answer. So square root of 21 is not a whole number, so our answer is irrational. So hopefully you're starting to see that anytime we have a square root or any type of radical sign in our answer that does not equal a whole number, it's irrational. Anytime you have a fraction or a whole number for your answer, it's pretty much always going to be rational as long as the fraction doesn't have any radicals or pi's. So like what I was saying, if we have this as a fraction, like if we just had 4 divided by root 3, that would be irrational. But anyway, so 4 times square root of 12 divided by the square root of 3. So another way to write this would be 4 times the square root of 12 divided by 3. But we know that 12 divided by 3 is 4, so I'll have 4 times the square root of 4. Hopefully you know that the square root of 4 is 2, so this would be the same as 4 times 2 or 8. So since we get a whole number for our answer is rational. Finally on the last one, so first thing I want to check, can the whole numbers be simplified in this fraction? No, they cannot. Can the two square roots be simplified? Yes, they can. So I'll have 5 times the square root of 25, still divided by 3. So what I did here, this is 5 times the square root of 75 divided by 3, all divided by 3 still. 75 divided by 3 is 25. Square root of 25 is equal to 5. So I'll have 5 times 5 divided by 3, which is 25 divided by 3. So this is a fraction with only whole numbers on the numerator and denominator, so this would be rational. Moving on to the next page. So we got to complete these statements with always, sometimes, or never. And then we got to list some examples. If we have a rational number plus a rational number, will it always, sometimes, or never equal another rational number? So for example, if I have, that's not a number, that's a letter. If I have like 9 plus 3, those are two rational numbers. That would equal 12, which is a rational number. So this is rational, rational, rational. If I have 1/3 plus 4/3, those are two rational numbers. That would equal 5/3. So rational, rational, rational. So if you choose any two rational numbers, you add them together, your answer is always going to be a rational number. So this answer would be always. So a rational number multiplied by an irrational number. So if I have like the square root of 2 times a rational number times 2, that would just equal 2 root 2. So I meant to use a different color here. Let me do this with a different color. So if I have 2 times the square root of 2, so you don't have to erase that, I'm doing the same thing. It would be 2 root 2. So this is the rational number. times an irrational number equals an irrational number. But what if I do 0 times the square root of 2? That equals 0. So that's a rational number times an irrational number equaling a rational number. So we just discovered that when we multiply a rational times an irrational, it could be either irrational or rational. So sometimes it will equal an irrational number, sometimes it won't. So a rational number raised to the 0 power will blank be equal to 0. So anytime you raise any number to 0, will it ever be equal to 0? No. Anything to the 0 power always equals 1. So this is never, it will never be equal to 0. So a rational number multiplied by an irrational number, irrational times irrational. So if I have square root of 2 times square root of 3, that equals square root of 6. So this is irrational times irrational equals irrational. But what if I do square root of 3 times the square root of 3? That equals 3. So that's an irrational times an irrational. That equals a rational number. So if you multiply two irrational numbers together, it could equal an irrational number or it could equal a rational number. So this is sometimes. So sometimes when you multiply those two together, you will get an irrational number. And that is it for today's notes.